Hey guys, in this video we're going to continue talking about our study of systems of equations. Now in Algebra 1, the only thing we looked at were systems of two equations with two variables. So we solved for an x and a y, or sometimes an a and a b. In Algebra 2 we're going to expand that and we're going to start talking about systems of three equations with three unknowns. So that means our systems here in this chapter, or in this lesson, are going to have three variables. I will give you some fair warning. These problems are going to seem a bit tedious at first because, well, you'll see why here in a minute. They do get a little bit better with some practice, but at first glance, it's going to seem a little bit maybe overwhelming. So just bear with me on these. And again, like all things, the more you practice, the better they become. Okay, so let's look down at number 1 here, and we'll just jump right into this. For this system, again, you see we have three equations, and we have not one, not two, but three different variables. We have an x, a y, and now we're adding a z to the mix. So the same thing is true for a system with three variables or a system with four variables as is with a system of two variables. You have to find the exact combination of numbers that works in for x, y, and z in all three equations. Okay, so when you're solving systems with two variables, we call that an ordered pair. When you're solving systems with three variables, we call that an ordered triple. And so you'll see what our answer looks like here at the end. But I want to find what x, y, and z all have to be so that all three of these equations are true. So what I'm going to do is I'm going to start by trying to do elimination on two of my equations. Okay, and for your sake and mine, I would prefer you number your equations at the very beginning of every problem. So I'm going to number my equations now just with a 1, a 2, and a 3, and that's just going to help you keep really organized work as you go through this. Okay? So the first thing I'm going to do is I'm going to look for opposite coefficients. And if you look at equations 1 and 2, we have a negative 1y and a positive 1y here. So if I take equations 1 and 2, x minus y plus z equals 1, that's equation 1. And equation 2 is x plus y plus 3z equals negative 3. And I do elimination on just these two equations, that's going to get rid of my y variable. So that's going to give me 2x plus 4z equals, this would be negative 2. So now I have a new equation with two variables, but y has gone away. Okay, so I can't solve for anything yet because I still have two variables here, so I can't find x and I can't find z yet. But what I'm going to do is I'm going to call this one equation number 4. Now I'm going to go back to my three original equations. And over here I got rid of y by adding equations 1 and 2 together. Now I want to try to get rid of y again by taking either equations 2 and 3 or 1 and 3 and doing elimination on them as well. So I'm going to pick two different equations, not 1 and 2 again, and try to get rid of y again. If you look at equation 2 and equation 3, again you see we have a positive y and a negative y, and so I can do elimination on those two equations now to try to get rid of y again. So now I'm going to take equation 2, x plus y plus 3z equals negative 3, and equation 3, 2x minus y plus 2z equals 0, and do elimination again on those two equations. So my y's again will cancel. This time I get 3x plus 5z equals negative 3. And I'm going to call this equation 5. So now, by doing elimination on two different sets of equations, 1 and 2 first and then 2 and 3, I've created two new equations that each only have an x and a z on them, equation 4 and equation 5. Now if I put these two equations together, so equation 4 and then equation 5, I'll just write it down here. 3x plus 5z equals negative 3. This is going to look an awful lot familiar to you. This is going to be a two-variable system. And so now this system right here, we can solve like we normally would by just doing elimination to try to get rid of either x or z. So it's like we've created a new problem that we're used to. So I'm going to try to get rid of x here because I have a 2 and a 3. So now I'm just going to do regular elimination. I can multiply my top equation by negative 3 to get a negative 6x. Bottom equation, I can multiply it by positive 2 to get positive 6x. and that's going to give me negative 6x minus 12z equals positive 6, and 6x plus 10z equals negative 6. Okay, and so here my x's will cancel, and I get negative 2z equals 0. So that means z is equal to 0. Okay, so now I have found one of my three variables. And this is going to make life a lot easier now that you know one of your three variables. Okay? So now what you're going to do is, you know z equals 0. You have two equations up here, 4 and 5, that each only have an x and a z on them. So now you can go back to either one of these equations, plug in your 0 for z, and now you can find x. And so I'm going to take equation 4 and do that. Notice every time I use one of my original equations or one of these two I'm numbering it, just so when you're doing your work and I'm grading your work, I can see where you're getting some of your work from. Okay, so I'm taking equation 4, I'm plugging in now a 0 for z, since we've solved that one. And that's going to give me 2x. This will cancel, so you'll just get 2x equals negative 2, and so x becomes negative 1. Okay, so now you have two variables solved for, x and z. Once you get those two variables solved for, all you have to do is go back to your original equations, 1, 2, and 3, and pick one of those equations. So I'll just take equation 1, and you're going to plug in for the two variables you know. So equation 1 was x minus y plus z equals 1. Again, now I know x is negative 1. I know z is 0. So this is negative 1 minus y plus 0 equals 1. So that gives me negative 1 minus y equals 1. If I add 1 to both sides, I get negative y equals 2. And so y must be negative 2. Okay, so now I'm going to take my three variables, I'm going to write what's called an ordered triple. In ordered triple, you would just put the variables in alphabetical order. So x is negative 1, that goes first. Y is negative 2, that comes second. And then we're going to put another comma, and z is 0, that goes third. And I'm going to close those off with parentheses again, because these are three different variables. So this is my ordered triple, negative 1, negative 2, 0. Okay, let's try a second one, and again practice this process again. So the first thing again I want you to do is label your equations 1, 2, and 3. And we're going to try to do elimination on two of those equations to get rid of one of our variables. I see a negative 2y and a positive 2y down here, so I'm going to choose equations 1 and 3 this time to try to get rid of y again. Again, you don't have to get rid of y every time. You can try to get rid of a different variable, but you want to try to get rid of one of the variables first by doing some elimination. Okay, so when I combine, my y's are going to go away, so I get x plus 2x is 3x, and this one also, notice my z's go away. So I kind of luck out on this problem, because just doing one elimination step, y and z both go away, so now I get 3x equals 6, and now I can solve for x right away. I know x is going to be equal to positive 2. So sometimes you'll look out and you'll find a variable right away, which is really, really nice. Now I'm going to go ahead and I still can't plug 2 into one of my original equations, because all three of these equations have an x, y, and a z. You can only plug into these original equations when you have two variables solved for. So I still need to do elimination again on either equations 1 and 2 or 2 and 3 in order to get rid of another variable, but it helps that I know x equals 2 at least. So let's see, I'm going to try to get rid of, again, y here, so I can take equations 1 and 2 to do that. So equation 1 is x minus 2y plus z equals negative 4, and equation 2, what I'm going to do is, since there's a positive y down here, I need to get a positive 2y to cancel out this negative 2y. So I'm going to go ahead and I'm going to multiply equation 2 by 2. So I'm taking equation 2 and multiplying it by 2. So that gives me negative 8x plus 2y minus 4z equals 2. So sometimes when you're doing this elimination step with these two equations, you've got to multiply. So my y's are going to go away. I'm going to get negative 7x minus 3z equals negative 2 here. Okay, but now since I know that x is equal to 2, so this would technically be equation number 5, since it's the second one I've created. Now I can take equation 5 and I can plug in this x equals 2 directly to it. So now I have negative 7 times 2 minus 3z equals negative 2. That gives me negative 14 minus 3z equals negative 2. So add 14 to both sides, I get negative 3z equals 12, and so z comes out to be negative 4. So now I have an x, I have a z. Again, once you have two of your variables, now you can plug back into one of your three original equations to find the third variable. So I'll take equation 1 again, and I know x is 2. I don't know y, so this is going to be 2 minus 2y. And then I know that z is negative 4, so this is going to be plus negative 4. And now we have equals negative 4. So I have a 2 minus 4, that's going to give me negative 2 minus 2y equals negative 4. And then if I add 2 to both sides, I get negative 2y equals negative 2. Y comes out to be positive 1. So my order triple for this problem, it's going to be 2, 1, negative 4. Okay, last problem. Sometimes it might be better to use substitution rather than elimination when you're solving a three-variable system. So I'm going to show you a problem where you can use substitution as well. So for example 3 here, if you look at your three equations, again we're going to number those 1, 2, and 3. You notice equation 2 is missing a z, and equation 3 is missing a y. Okay, so what I'm going to do for this problem, and again, you could do elimination on this, that's fine, but I'm going to take equation 2, and since it's only got two variables, I'm just going to take it right away, and I'm going to solve for x. So, since it's x plus 5y equals 9, if I just subtract 5y from both sides, that gives me x equals negative 5y plus 9. And what I'm going to do now is I'm going to plug in this negative 5y plus 9 in for x into both equation 1 and equation 3. And that's going to create my two new equations, equations 4 and 5. So I'm going to plug this in up here and then also down here for x. So starting with equation 1, we have 2 times, instead of x, we're plugging in the quantity negative 5y plus 9. Plus 3y minus 2z equals negative 1. This gives me negative 10y plus 18 plus 3y minus 2z equals negative 1. Combine my y's, I get a negative 7y minus 2z. And then I can also subtract this 18 over to get negative 19 on this side. So I'm going to label this as equation 4. So now I have a new equation with no x in it. Negative 7y minus 2z equals negative 19. And now I'm going to do the same thing here in equation 3. I'm going to substitute that expression negative 5y plus 9 in for x. So that gives me 4z minus 5 times the quantity negative 5y plus 9 equals 4. So I get 4z plus 25y minus 45 equals 4. I'm going to reorder my variables, so though the y comes first, I have 25y plus 4z now, and when I add 45 to both sides, I get 49, and so this is going to be equation number 5. So now I can take equation 4, and I can take equation 5, and treat that as my new two-variable system, and now I can just do elimination on those two to start solving for y and z, just like I did on problem number 1. So this is going to be now just like a new two-variable system. What I'm going to do is I'm going to multiply this top equation by 2 so that I can get a negative 4z here, and then my z's are going to cancel. So when I multiply this by 2, I get negative 14y minus 4z equals negative 38. Bottom equation, I'm going to leave it alone. So 25y plus 4z equals 49. Combine those like terms, your z's are going to go away, and I'm going to get 11y equals 11, so y comes out to be positive 1. So now we have y. Now I can plug y equals 1 into either equation 4 or 5 to get z. So I'll take equation 4 now. And now I know negative 7 times y, which is 1, minus 2z equals negative 19. Add 7 to both sides, I get negative 2z equals negative 12, and so z comes out to be 6. And then finally, just like the last two problems, once you have two variables solved for, you can go back to equations 1 through 3 and plug in to find your third. Now for this one, I cannot plug in, I need to solve for x. So I can actually, I could plug into equation 1 if I wanted to, but notice equation 2 and 3, both of those have an x in there, so I can also plug into 2 and 3, even though they're missing a z and a y in each of them. You can still plug in to each of those equations to solve for x. So I'm just going to take equation 2. X plus 5y equals 9. Okay, there's no z in that one, so I don't have to worry about plugging in a 6. But I know my y is equal to 1, so I'm going to replace y with 1. That gives me x plus 5 equals 9. And so that tells me x has to be equal to 4. And so my order triple for this one, x is 4, y is 1, z is 6. So the order triple is 4, 1, 6. Okay, we'll definitely practice this the next time I see you in class. Again, I know it seems like a lot of work right now, and it is more work than probably what you're used to doing for single problems, but it does get a little bit easier with practice. Feel free to go back and watch anything in the video that you didn't get the first time, write down a question or two, and I will see you the next time we have class. Until then, have a nice day. You are all wonderful people.